My official title is Warning Coordination Meteorologist at the National Weather Service in Mobile, but that's just fancy for the public outreach and community preparedness and things like that. My background, I am originally from Northwest Louisiana. I graduated with my bachelor's degree in atmospheric sciences from the University of Louisiana Monroe. We did beat Alabama once in our history, so that was our pride and joy. Then shortly after graduating, I went to work as what was then called a meteorologist intern at the National Weather Service in Birmingham. And then while at Birmingham, I got a master's degree, then went to Huntsville as a meteorologist, stayed in Huntsville, Alabama for about 8 years as a meteorologist, then a lead meteorologist, then the WCM. And then back in December, I moved to NWS Mobile as the warning coordination meteorologist. So I have toured the I-65 corridor in Alabama. So now I'm going to talk to you a little bit about the National Weather Service. So the National Weather Service, we are part of the federal government. We're nested under the National Oceanic and Atmospheric Administration. So if you go, especially over in Dauphin Island, go down along the coast, you'll see the NOAA emblem. We're part of that. NOAA is within the Department of Commerce. So for the National Weather Service, our mission is to protect life and property. We are the only entity that can issue public watches, warnings, and advisories. There is the private sector that can do it for private entities like contracts for rail, commercial, things like that. But for the public, we are the only entity that can legally do the weather watches, warnings, and advisories. There are 122 weather forecast offices across the country, including an office in Puerto Rico, an office in Guam, and an office in the American Samoa. All of these offices, we are there to kind of get that focus, that local, smaller scale knowledge. A lot of us work at our respective forecast offices for many, many years, so we know the area. That's particularly important, especially, along the coastline when you've got landfalling hurricanes. It's good to have somebody there, kind of boots on the ground, that knows what that coastline, how that's going to be impacted. So that's Huntsville, that's where I came from, and then you can see Mobile, we're down here along the coast. We have 20 counties that we cover. So each county warning area, some are huge, some are small. Atlanta has 96 counties, we have 20, don't ask me why that is. But that's us in a nutshell. In addition to the weather forecast office, looking at the local level, we also have regional and national centers as well. Our regional headquarters, they're looking at more of kind of the program management. We have a lot of different programs, tropical, public, fire, aviation, all that. So they're looking at it from kind of a broader scale, and then of course we have a national headquarters that looks at the entire agency as a whole. In addition to those regional headquarters, we have river forecast centers. Those river forecast centers are focused on point-specific forecasts at individual river gauges along the main stem rivers and their tributaries. So the Mobile River, Tombigbee River, Alabama River, Fish River, Styx River, Bayou Sara, those are the type of kind of main stem and tributaries that they're looking at. So they take a lot of different data. How much rain are we expecting? How much rain have we had? What's that current gauge? And they do a lot of fancy stuff that's over my head, and they get that forecast. We also have what's called a Center Weather Service Unit. Center Weather Service Units are probably one of the cooler jobs in the Weather Service because they are actually located with the FAA at several of the larger airports around the country. So the Atlanta airport, Memphis, Fort Worth, Houston, Jacksonville, Miami. And what they do, they have that direct contact for planning purposes. So remember, we're here to protect life and property. So we're trying to mitigate, hazards, help with planning, stuff like that. And so the Center Weather Service units, they have that direct contact with the FAA, so that's a really, really cool job. In addition to that, we have national centers. So the national centers, you're probably familiar with the National Hurricane Center. They produce the hurricane forecast. Then we take that and we put it in a localized format and then message with our partners and the public. Storm Prediction Center, have we heard of them? That's where our convective outlooks come from. So if we have marginal, slight, enhanced, moderate, high risk of severe weather, tornado watches, severe thunderstorm watches, those are collaborated with the severe or the Storm Prediction Center as well. They also have a fire weather component. We don't get a lot of fire weather concerns here that often, but when we do, they provide an outlook for fire weather as well. There are other Climate Prediction Center, the Environmental Modeling Center, Weather Prediction Center is another one that has an impact on us because they help provide the precipitation accumulation. So how much liquid rainfall will we have? They also kind of help us with the type of precipitation. Is it rain? Is it snow? Is it sleet? Things like that. They also produce the surface weather maps and some of the upper air maps too. So they kind of have that broader picture of the United States. And then there's Space Weather Prediction Center and a couple of others as well. So the Space Weather Prediction Center, they are located in Boulder, Colorado, and so they're looking at solar storms and what the probability of like solar flares, things like that. So they have an Aurora Borealis forecast. And then they kind of help provide, you know, if there's going to be a large, like, you know, electromagnetic storm or something like that that might take out some communications, they kind of help with that. So for the most part, we don't really collaborate with them that often, and a lot of the public doesn't either, but they do provide that service at the national level. So looking kind of at the local level, the Weather Forecast Office. So what do we do at the Weather Service? A lot of what we do is forecasting and interpreting the weather. So we're looking at a ton of different data sets, and we're trying to find in a 7-day period what are our impacts going to be. We do this for the public forecast, which is the 7-day forecast that you can go see if you go to our website or you, what have you. But we also do it for fire weather, for aviation, for marine hazards, or just marine forecast. So it goes beyond just highs, lows, % chance of rain. We also issue the warnings for any type of impact weather. So hurricanes, so tropical storm watches and warnings, hurricane watches and warnings, those come from us. Severe thunderstorm warnings, tornadoes. We'll also sometimes, we don't really send a warning for lightning, but we do have products that we can. Flooding and then winter weather, which Mobile does get every once in a while. But we have to know how to do all of that even if we don't get it. So when we are not in an impact period, when it's more benign weather, we are doing a lot of training, researching. So we take a lot of event reviews. So if we are forecasting a specific event, once it's over, we'll go back and look, how did that go? What was our, you know, where were we right? Where could we improve? How was our messaging? How was the response to that? And then we also, this is kind of the key part of my job, is working with the local governments, the public safety officials, and the community preparedness program. I can sit here and send out warnings all day long, but if you don't know what they are or what to do when you receive it, then, you know, what's the point? Not what's the point, but you get what I mean. So a lot of public outreach. We're getting back into that after that time warp that we all went through with the pandemic. So that's kind of a really broad look, but like I said, a lot of training, a lot of partner visits. We work very, very closely with our emergency managers. If you don't know your emergency manager, they are just heroes of the counties. They are amazing organizations that are there to mitigate and help with disasters. So we're constantly working with them before the significant event happens so that if it happens, we have that relationship. So now let's look at the type of information that we use. And this is a list, and I'm going to go into all of this step by step. So first is the radar. If you ever go down Airport Road by the airport, you'll see, or Airport Boulevard, you'll see the big golf ball. So that's our Doppler radar. It's just a very, very big dish inside of a dome. That dome is called the radome. And basically, what it does is it sends out a pulse of energy. Once it hits an object, then some of that energy is received back. And we have two beams. We have one beam that goes horizontal and one beam that goes vertical. So not only based on that energy, there's a ton of algorithms. I'm not a tech person. There's a ton of different algorithms and things that the radar can then take that information and tell us within a degree of accuracy what the particle was. So if that vertical and horizontal are uniform, raindrop. If it's not uniform, maybe hail, maybe a piece of wood, maybe a leaf, maybe a bug. Based on how much energy is returned, that tells us how much of that is. So whenever you're looking at your favorite broadcast meteorologist and you see kind of the image that goes from blue to green to yellow to red, so that's how much energy, the amount of energy that's reflected back. It can also tell us based on how long it took to go and hit that particle and how long, that can tell us how fast it's moving. So that's how we can look at storm direction. It's also how we can look at if there's any rotation, because it can see this side is moving this way, these particles are moving this way, and it can tell that based on how that beam of energy is hitting that particle and coming back. So it's really, really cool. Doppler, or Weather Service Radar 88D, these were built in 1988. Over the course of the last 35 years, and I didn't do that math in my head, that's just the year that I was born. In the last 35 years, there have been a lot of what we call service life improvement projects that go in and reconfigure the algorithms and the processors and things like that to keep it improving. The future of radar technology, we'll be able to just take that beam and send it wherever we want it. So the radar, right now, it's constantly spinning, and it has different degrees of tilt. So it does one whole rotation, then it clicks up, does another, clicks up, so that we can see that whole storm structure. But eventually, instead of having to wait for it to go all the way around, we'll just be able to move it where we want. So that's exciting times in 10, 15 years. So weather satellites, anybody know how high satellites are? How high above the Earth's surface? 22,000 statute miles above the Earth's surface. So right now, the satellites that we use, there's a lot of different, obviously telecommunication satellites, things like that. The satellites that we use for the weather are called geostationary operational environmental satellite. Very, very long, but we just call it GOES. So geostationary, GOES, and we have a GOES 16 and a GOES 17. So think about me standing here, and I'm trying to think of how to explain this. The GOES is geostationary, so it never moves. It's constantly in that same spot in the orbit. And it's just having to go around really, really, really fast as the Earth spins. So it's constantly kind of basically running to keep up with that same spot of the Earth. So that's what. So it's always over the same spot. It never moves. So it's just constantly kind of running around it. We got GOES 16 back in 2016, GOES 17 in 2017. So GOES 16, that's a look at GOES 16. That's a visible satellite. So that's what it looks like from outer space, from the visible light. So you can see the clouds, things like that. So again, it's always in that same location, no matter how No matter what, it's always in that same location, but we can zoom in. So you're probably thinking, well, why do I need to look at South America? It can zoom in. And with GO16 is on kind of the eastern northern hemisphere, and then GO17 is kind of out in the Pacific Ocean, so that we have that kind of overlap of the United States. With GO16, the technology is so advanced that we have the ability to go even smaller and get data minute by minute. And we have what's called a mesoscale sector, meso meaning small, scale, obviously. So if we overlay both of those sectors over top, we can actually get images every 30 seconds, which is really cool when there's a hurricane way out in water not impacting anybody. So that's kind of a look at weather satellites. We use these kind of as a real-time look. We can also use these, like you can see over the plains, you've got areas of cloud cover, areas of sunshine. That's a boundary for a heating boundary. So that's a location that we can look at to see, okay, maybe thunderstorms are going to start developing there. So another thing, weather balloons, that's another big part of our the data sources. Weather balloons, exactly as it says, fill up the balloon. It's big, it's 5 feet in diameter, so I can sit inside of it. Once we're ready to launch, we go far away from all of the buildings, and then we launch. Attached to that weather balloon, you can kind of see a parachute, but at the very, very end is what's called a radiosonde. A radiosonde, it directly measures the temperature and the relative humidity. It also has a GPS device inside of it. So from that, we can get the temperature, the dew point temperature, the wind speeds at each different height in the level. So that whole picture, we get a solid picture of the atmosphere at that location. It goes from the surface, which is typically about 1,000 millibars surface pressure, all the way up to about 4 millibars, so at the very, very top of the atmosphere. As it's rising, it's expanding. By the time it gets up to that very tip top of the atmosphere, it's roughly the size of about a 1,400 square foot house, that balloon. So that's how much it expands. But with that data, not only can we see that cross-section of the atmosphere in real time, which helps us determine the environmental parameters then, so we can kind of see, is the environment supportive of a certain weather scenario, whether it be snow or severe weather. But that also gets incorporated into our weather modeling. So weather modeling, think of every point on the surface of the Earth, every point in between that, and just every point, everywhere on the surface of the Earth. Then think about having to forecast all of that every hour to every 6 hours. Can't do it. So you have supercomputers. The balloon, the data that we get from the balloon goes into what we call our forecast models. And those are what we call like the initial conditions. So that's how we start, and then it takes just thousands and thousands and thousands of calculations, expands it out, and then that's how we create our forecast. So here's a really, really quick example. So we have 4 different model solutions. We want to know where that red X is going to be. Any clue? I don't know. How do we do it? How do we determine it? There's a couple of ways. We either look at a consensus. So what model has been the most consistent with that placement? Where is that X in all of the model solutions? Is it going all across? Is it in one model run? Is it over the Texas Panhandle? Is it over Mississippi? Or we can take an average. So looking at this, taking an average of them all, maybe I want to put it over East Texas. Those are just some of kind of the techniques that we use for forecasting, and it's very, very dependent on what the setup is. A lot of what we do is look at how well the models have done in the past with a certain scenario, and we put kind of a weighted trust in those specific models. We also might look at, see, where is that particular thing, like that X now? How well is the model doing with it at this specific time? So those are kind of the ways that we forecast. So another question, anybody know what causes the weather? The sun. The sun is where it all starts. We know it's important, we know we need it, but why is it causing weather? Well, sun heats the earth through solar radiation. That solar radiation then gets re-emitted as extraterrestrial radiation, or terrestrial, not extra, that would be an alien, as terrestrial radiation. And as that happens, it warms the kind of air over it. So you can see the closer you are to the Earth's surface, the warmer it is. And then up until you get to a specific point in the atmosphere, it gets colder and colder and colder. So sun heats the Earth, Earth emits that heat back. Well, unfortunately for the atmosphere wants even heating everywhere. But that can't happen because depending on where you are, the Earth is heated at a different rate. Closer to the equator, you get more incoming solar radiation. As you go out towards the poles, you get less and less radiation. So it's heating differently. John's going to also go into a little bit more of that heating with tilt and axis and spins and stuff like that, but just know it's not getting the same, even if it's, still and doesn't move and stuff, it's going to heat a little differently. In addition to that, land and water heat differently. Land heats up faster and to a higher temperature than water during the day. At night, it cools faster and gets cooler than the water around it. So water and land heat differently. That's why you have fog. So closer to fog, or closer to bodies of water whenever it's rained really hard, that land is cooling at a faster rate than the water, so it causes that water to become super saturated, and then you get water particles. Okay, so remember, atmosphere wants it to be equal, wants to have that equilibrium. Can't happen. So then what happens with all the uneven heating? You get uneven pressure distribution. So we'll talk about high and low pressure in a second, but uneven heating, uneven pressure distribution, atmosphere is even angrier because it wants everything to be the same. So what does it do? Well, it sends some of the air from the high pressure to the low pressure. What's that called? It's on the slide, but what's that called? That's the wind. That's why we have wind. So the air blows from high pressure to low pressure. That causes wind. And then going a little bit kind of deeper into that, our high pressure, cold air sinks, warm air rises, warm air less dense than cold air. So with that sinking motion, you get a lot of clear skies, mostly calm weather, and it causes, that sinking motion causes air to then expand outward. Again, why you have air going from high pressure to low pressure, because of that sinking motion. Everybody with me? Low pressure, on the other hand, rises. So you've got all of that air coming together at the same time. It has to go somewhere. It can't go down because of the earth, so then it causes it to rise. Rising air is what causes a lot of our thunderstorms. That's what causes our thunderstorms. That's what causes kind of what you consider to be like impactful weather. Temperatures are weather too, but when we're talking about kind of more of those impacts of like rain, things like that. So it's what we call convergence, then it rises to try and fill in that air. So on a typical weather map, usually you'll see blue is high, low is red. A cold front separates cold air from warm air. Conversely, a warm front separates warm air from cold air. The direction of these triangles, cold fronts are always going to have triangles. Warm fronts are always going to have those little bubbles. The direction of those is the direction that that front is moving. So why does a cold front and a warm front, except when we're talking about severe weather, warm fronts are really important when it comes to severe weather. But cold fronts, that's where you're going to have your more volatile weather, because basically that cold front, as it's moving, most of the time it's moving a little bit quicker, because remember, cold air is more dense than warm air, so it has an easier time pushing that warm air out. So it almost is like kind of a wall pushing it. So again, it has to go up. The wind, the air has to go up as it's pushing. So it causes it to go up really, really fast. So then you can get volatile thunderstorms, severe weather, tall thunderstorms. Warm fronts are a little bit more sloped because it can't get through that cold air as easy. And so that you have a gentler slope. So a lot of times you'll have kind of like your rainy days where it's just like a constant rain and it's actually really nice. Those are usually by a warm front. Now where you have that warm front move, it's where you have really, really warm air, a lot of energy. That's where you start to get into the bad, severe thunderstorms when the cold fronts are moving. Fronts, also boundaries. So when we get thunderstorms during the summertime, those are usually caused by boundaries. Those boundaries can be in the form of a leftover outflow boundary from another thunderstorm. So think of a rain. When it hits the earth, it's cooler than the air around it. So it kind of creates this mini cold front. Or a sea breeze. Whenever sea breeze, that's still something that I'm getting used to. I came from way landlocked, but sea breeze is another thing where you've got that cooler air that creates a boundary. So even though they're not cold fronts and warm fronts, think of boundaries. Those are kind of the same thing. And now I'll hand it.
All right. That's a good introduction. That tells you a lot about how we forecast weather, how all the different systems that we have that operate. I'm going to go back a little bit further back and talk about the big systems that we have. But I always like to start out with a test just to make sure people are listening, and we'll see who knows. So generally, what is the hottest month? So I'm going to call these months out, and y'all raise your hand if you think that's the hottest month. July. Okay. January. Nobody fooled me with it. It depends. Okay. There's a few that know my trick. It was actually a trick question. Now, if you're talking about Mobile, Alabama, obviously July and August are going to be the hottest months. And if you've lived for this past month or two, you know that for a fact. But if you're talking about the whole world, not necessarily so. And that's because what we have is, just like Jessica was saying, we have uneven heating. Now, all of y'all know, or maybe you don't know, the Earth is tilted 23.5 degrees. I got my globe and I looked at it and it's tilted off to the side. I said, oh, this thing is broken. But that was just an attempt to show what's actually happening in the world. So when you have an Earth that's tilted 23.5 degrees to the side, you have different heating there. So around the equator, and I have a pointer here. Oh, yeah. So sunlight is directly overhead from the Tropic of Cancer to the Tropic of Capricorn at different times of year. So anybody know where the Tropic of Cancer and the Tropic of Capricorn are located? They're located at 23.5 degrees north and south latitude. It's because that Earth is tilted. That basically is just a line that marks how far the sun gets to where it's going directly onto the Earth. Okay? So that the sunlight is directly overhead on the Earth at 23.5 degrees north. Now notice that's just a little bit south of the tip of Florida. So, and we are in Mobile are about 30 degrees north. So we're a little bit further north. So the sun would never be directly overhead where we are. But it's pretty close. So anybody want to guess what time of year this is? I know this is a hard one. Well, you're real close. This would actually, just by looking at this, I'd say this would be about June 20th to 22nd. Now, you can tell, boy, that John has a sharp eye. He can see everything. Well, not really, because I know there's 4 times a year that are important for the weather. And if you look at where it says June 20th and 22nd, that's pretty much like that last picture we saw, where the sun is directly overhead at 23.5 degrees north. The thing is, even though the sun's not directly overhead in the northern hemisphere, it is pretty close to being directly overhead. So we get the most direct sunlight that we're going to get all year. And we call this the summer solstice. Now you're going to find that all of these terms are northern hemisphere specific. Doesn't work for the southern hemisphere because they're just the opposite. They're having winter at that time. So as the earth rotates around the sun, it's more direct sunlight over the northern hemisphere, June, July, August, May, around that time. And so that's why we have summer. What are they having in the southern hemisphere? Winter, okay? So that's the first day of summer is June 20th, right in there between the 20th and 22nd. The earth rotates around to September, and the sun is directly over the equator at that time, okay? So the equator is getting all that sunlight, and it's pretty much even on north and south. But this we call the autumnal equinox, and that's when fall starts. You're going around to December 21st for the 22nd, pardon me, and you have the winter solstice. That's when the sun is directly over 23.5 degrees south. So that's when the southern hemisphere is having their summer, and we're having our winter, and it goes on around to spring. So those are important things, and you see them on the calendar, and it just shows where the earth is and where it's heating and where it's not heating, so to speak. So there's a lot of differences between the northern and southern hemisphere. I think all these names came because the people that studied weather were mainly in the northern hemisphere, in Europe, the United States, and those areas. So, you know, they don't care about the southern hemisphere. They just wanted to give it the northern hemisphere names. So just to show you differences here, let's talk about Christmas. And we sing a song, I'm dreaming of a white Christmas. Well, in Australia, they don't have a white Christmas. In fact, they're going to the beach on Christmas Day. And not so much thinking about a white Christmas, okay? We are thinking about a white Christmas. And a few years ago, I don't know if you remember this, the National Weather Service, or NOAA, put out an article that said, hey, if you want to see a white Christmas, these are the states you go to. And our son and his family live out in Idaho, and I called him today, and I sent him a message and said, hey, y'all been there 7 years, how many white Christmases have you had? And he called back and said, well, I think it was 5 or 6. So there's a pretty high chance you're going to get a white Christmas if you live out in Idaho. Okay, so that's what makes the weather different around the world, the uneven heating, and that gives us our weather. Now, it kind of breaks down into 3 different climatic zones. And guys, I'm going to tell you, weather people are the most disagreeable people in the world. You can look anywhere on the internet, you can find 5 climate zones, you can find 7, you can find any kind of breakdown of climate zones. I'm talking about these 3 very simple climate zones that we look at. So, the northern one, around the North Pole, that's the polar zone. Sounds kind of cold, doesn't it? Yeah, and it is. Also, the South Pole So they're pretty much even on both sides of the equator. The middle one, the tropical zone, that covers the very warm places where between 23.5 degrees north and 23.5 degrees south, the sun is pretty evenly going to be beating down energy on that section, so that you always have the tropical zone. And then the temperate zones are between the polar and the tropical zones. Let me go into a little bit more detail on these. Now, here's the polar zone. The blue sections down here in Antarctica and up in the northern states, northern countries. Where are, give me some names of countries that would be in the polar regions. Russia, Canada, Greenland, yeah. Siberia, yeah. That's why the Russians always sent political prisoners out to Siberia. Nobody else wanted to live out there. Okay, I'm interested in Canada. You see, most of Canada is considered to be in the polar region, and that basically explains a lot. And I found a website that shows that explains something like 90% of people in Canada live within 100 miles of the U.S. border. So you look at those northern sections, and there's a reason nobody's living up there. Everybody wants to be as far south as they can so they can not be quite so cold. Actually, we were stationed in Tampa for 3 years, and there was a lot of Canadians that retired down in Florida. In fact, on the radio station there was one station that every day at noon would carry Canadian news. So, you know, it tells you they want to be warm just like we do. So the polar region's very cold, obviously. Okay, let's move on to the tropical region in the center of the earth. Okay, you can see the tropical regions in brown there. And Central South America, Brazil, Central Africa, and Southern Asia, those are all in the tropical regions. Now, some interesting things about the tropical regions. You don't have a whole lot of difference in climate year-round, because that sun is always close to being overhead, beating down on you. So if you're gonna look for a break in the weather, and you know, last 2 months we've had here in Mobile, pretty brutal, right? And we're all looking for a break in the weather, a little bit cooler times. But you don't look for that in the tropical regions, because the sun's always sending that energy down. Let's look at one example, Belém, Brazil. That if you've looked at a map, you know the Amazon River comes out into the Atlantic Ocean on the east side of Brazil. And Belém is just right off the Amazon, and it's just south of the equator. So look at the high temperatures every month, range from 87 to 90. You don't get a break in the weather, do you? So, I mean, and that's really pretty much what we're forecast for here in Mobile. High temperatures in July and August, 90, 91, and low temperatures, 74 or so. That's like weather in Mobile during July and August. Fortunately, it doesn't stay that way in Mobile. But that's tropical weather right there. Look at the precipitation. Now, precipitation is a lot different at a lot of places in the tropical regions. In Belém, they get most of their rain in January till April. And that's typical. In those regions, you have rainy seasons and dry seasons. And every place is a little bit different. Our daughter spent 2 years teaching missionary kids in Uganda. And I looked at the climate of Uganda. In fact, Amy and I went over to visit her in September, and I was concerned, you know, it's just right on the equator, and we are going to be sweating like crazy. But no, it was very comfortable because Uganda is about almost 4,000 feet elevation, and it's a high enough elevation that you don't get the super heat like you would in other tropical regions. So the tropics, pretty rough place to live. Of course, can't say that polar is a very nice place either. But guys, we struck the lottery when we lived in the temperate regions. You see, and don't let this map fool you. It's not just straight lines for the polar and tropical regions. But you see, United States, most of Europe is in the temperate regions. And that makes a world of difference in what our weather's like. Now again, let me show you Mobile, Alabama. Summer, high temperatures are average 90, 91. But during the winter, high temperatures average in the low 60s. And, you know, so that shows the climate here, and that is typical of climates in temperate zones. So you get some relief from the heat. And you have good growing seasons, but you also have when the growing season is not so good. But that's what we look for as far as the temperate zones. Now, I like to give an example here. I was stationed in Germany for 3 years. And you see, we get a little snow there in Germany. In fact, the white box back there was our weather station where we had our instruments. Y'all have come a long way since then. But I'd have to go out there every hour and take temperature, dew point, all the stuff. And but winters can be kind of rough there, and it would be cold, but summers were great. Notice this was probably in early summer, and notice I'm wearing a long sleeve shirt, which I wrote up because it warmed up in the afternoon, but the mornings were still kind of cool. Germany is in the temperate zone, but they're further north than we are, so their average temperatures are lower than what we have. So the temperate zone is where you want to live if you have a choice, okay? Now, let's talk about the difference between the tropical zone and the polar zone. There is a border between those, and think of the border as being the polar front, and that's kind of like a battlefield. The battle's going to go back and forth. Wintertime, the polar front pushes to the south, in fact, check it out, it gets almost down to the Gulf Coast. Now, that doesn't mean we're going to get a lot of snow and stuff, but it's going to be a lot colder than it is during the summer. During the winter, it's up around the U.S.-Canadian border. So you have different climates in the temperate zone. You have some relief from the cold or the heat. Okay, just a couple of more things just want to cover here. What's the rainiest city in the continental U.S.? Okay, they all agree on that one. Now, there is some controversy about that. Depending on how they define it, some people would say, hey, Seattle, Washington's the wettest. But let me just show you this article I found. If you look at the rainiest cities, it shows they're pretty much all on the Gulf Coast or the Atlantic coast. And the reason we have that is that they're getting all that moisture from the water, and you get a lot of rain during the summer. And y'all know afternoon thunderstorms are typical here, not this year, but generally you get a lot of afternoon thunderstorms. And just give you an example of this is a prognosis chart, actually from last Sunday looking towards today. And you see the rainy area and the hatched area is the thunderstorms, and that's where we get the rain, mostly during the the summer months from the afternoon thunderstorms.
So
I want to thank y'all for coming out. If you have other questions, we'll just stand here and talk as long as people come up and ask questions. So.